Calculus lesson 13. In this lesson, we will discuss on a library of functions, where we will try to draw a couple of functions and then discuss about that functions, about their properties, what they will do, and what they mean, etc., etc. Then we will discuss about the quiz 2 syllabus, which is next week actually. So these are our agenda for our today's class. And this is graphing functions from the, you can see graphing function and properties of the function. F of x equals to square root of x, then f of x equals to cube root of x, modulus of x, then some more functions will be here, then syllabus for the quiz 2. So these are the agenda. First of all, graphing and properties of functions, and first one is f of x equals to square root of x. So how can we draw a square root of x function? F of x equals to square root of x function. For drawing a square root of x function, first of all we take some values of x, we consider some values of x, and then we do the calculation for the value of f of x. So we will think about some values of x. Let's say if we put here 0, then square root of 0 means 0. If we put here 1, square root of 1 means 1. And if we try to put negative 1, what happens? Negative 1, what happens? If we put negative 1, this is actually undefined. The square root of negative 1 is undefined, so we will not have any value here. Then square root of 2, if we put 2 here, it will be 1.4 kind of. And of course some other decimal, we are ignoring it at this point. Then if we put 3 here, it will be 1.7 and some more decimals here. If we put 4 here, then answer will be 2 here in place of x. If we put 4, answer is 2. This way we can continue putting the value, and if we put any negative value, answer will not come, because square root of negative any number is not defined. Some of you may think, sir, we can bring some imaginary number, which is actually we cannot draw in this coordinate plane. We need some other things to draw that. So let's put here 1, 2, 3, 4, etc. And this is also 1, 2, 3. This is our x-axis. This is our y-axis. For first value, when x equals to 0, y equals to also 0. So this point, when x equals to 1, y equals to 1. This point, this is 1. One, 2, 3, like that. Now minus 1. For minus 1, we do not have any answer, so we do not have to draw anything there. When x equals to 2, y equal to 1.4, somewhat here. When x equals to 3, 1.7, somewhat there. When x equals to 4, y equals to 2, something like here. And if we put more value, then for 5 it will be like more than 2 something, some value which is more than 2. Then our graph will look like something like some curve, like some curve like this. Some curve like this. These are the value, these are the points that we had here. So this is the square root of x graph. This is the square root of x graph. you can see that there is the graph is not going in the negative direction. There is nothing here, here or here. There is nothing. The reason is because when we put the value, our answer only comes in this direction. That's why we have the graphs here. Now, if we want to discuss about the properties of this graph or the characteristics of this graph, we can see a couple of things. One thing is the graph actually has some. This graph actually has some lowest point, and that lowest point is here, which is 0. At f of 0 equal to 0, the lowest point is here. Then you can think about what can be the domain of this graph, what can be the range of this graph. Domain of this graph is, you can see, from the 0 to the positive infinity, and the range also will be from 0 to the positive infinity in the y direction. So domain and range, you can say that way. And you can see from the left to right, if you go, the function is actually, this is some increasing function actually, and it increases from the 0 to the positive infinity. The function is increasing, so this is the increasing function. Now the question is it some even function or odd function, or not even, not odd? What is that? This function is not actually not even, not odd, because it do not have any reflection for the y or reflection for the origin. So this graph is not even or odd, not like that. Okay. So, and these are the properties of this. These are the properties of this function. These are the things that we understand by looking at this function. Okay. And we have actually the graph. This is the graph. You can see this graph and our graph is actually same. And domain and range is all real number. These are the properties. Domain and range is all real numbers. Oh, another thing is x-intercept and y-intercept as 0, 0. You can see 0 at 0 is the x-intercept, y-intercept both. The function is not even, not odd. The function is increasing from 0 to the plus infinity. From 0 to plus infinity, the function is increasing. And the function has absolute minimum at x equals to 0. This is the lowest point. This is the most absolute minimum here. This is the lowest point of this function. So by looking at some function, actually we understand a couple of things. These are the things that we understand from this graph. And then if we try to draw the cube root of x function, cube root of x function, the process is similar actually. The process is same. X, then f of x. When you put 0 here, answer is 0. When you put 1, answer is 1. When you put 2, cube root of 2 equals to cube root of 2 equals to 1.25. 1.25. 1.25. Cube root of 3 equals to 1.44. We can ignore actually all the decimals, extra decimals, because we do not need that extreme precision at this point. But what about the negative values answer? Actually, if we put -1, now in this point answer will start coming. -1, answer will be -1. If we put -2, so answer will come -1.25. -1.25. Like this. Continue. You can continue it. From the calculator, you will see if you put here negative, now you will get the answer here, because this is 3. For odd number here, actually you will always get the solution, always get some answer. For even number here, it will be undefined. So that's the catch here. This is our x-axis. and this is our y-axis. Just to make things clear, let me give some extra large value so that you understand the final shape of the graph where it will go. Suppose if we put here, let's say 8. If we put here 8, cube root of 8 means 2. If we put here 8, cube root of 8 means 2. And if we put minus 8, it will be minus 2. So this is our 1. Although we may not be able to put this big value, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, etc. 1, 2, 3, 4, 5, 6, 7, 8. So for 0 we have 0. Suppose this is 2, this is minus 1, and this is minus 2. For 0 it is 0, for 1 it is 1, which is here. For 2 it is 1.5, so 2 is here, 1.5 is a little bit higher, etc. For 3 it is 1.4, 1.4 is somewhat, like little bit higher. Then for 8 it is 2, that means 2 and 8 is here, something like this. And this is 1 minus 1 is here. Then for minus 2 it is little bit higher. Minus 3 it is little bit higher, like 1.25, 1.44 and 1.25. That's the gap between them. Then for minus 8 it is 2, 2 is here, minus 8 is here, something like this. Just to get some sense, like where, in which direction the graph is going. Maybe the graph goes up, goes down, where it is going, just to get the sense. So the graph is like this, and the other value, there is a value here, another value here, another value here. Then this part of the graph is like this. This is like a snake walking, okay? Sorry. So this is the graph for cube root of x. Cube root of x, fx equals to. So this is the point, and it goes. Let's look at the graph from our book. We can keep it here also. So see, this is the graph. This is the graph. So same shape, same shape of the graph, and the values is taken. Let me now clean it up, since they are same. And we have the values here. Some calculation is also shown here. These are the properties of the graph. You can see for the domain and for the range. The domain is in the both positive and negative direction. Positive direction of x and in the negative direction of x we have the graph. Then graph is up and down in the both direction, that means all real number. X-intercept is at 0, y-intercept is also 0. The graph is symmetric with respect to origin, this one and this one. See, corner same. So origin is symmetry, that means it is odd function. The function is increasing from this. You can see if you come from left to right, if you come, this is the left side, if you come from left to right, your graph start increasing and it keeps increasing in the whole direction. So that's why it is an increasing from function from minus infinity to plus infinity. Minus infinity to plus infinity, the graph is increasing. The function does not have any local minimum or any local maximum because both sides we have infinity. There is no local minimum or maximum here. Even there is no something like here, something like this in the graph. Suppose if there is something, some figure like this, then we can say that there is a maximum here, there is a minimum here, there is another minimum here, there is another maximum here. If there is this kind of shape, then we can actually say that we have this. But our graph do not have any of this kind of corner, somewhat like this, increasing one side, decreasing another side, this kind of, or this kind of thing. This is our local maxima, this is our local minimum, but our graph do not have this shape. That's why we do not have this in this graph. So this is the properties of x cube graph. In fact, from all the graphs, if we look at the graph closely, we get some this kind of properties. We have modulus of x graph here. Modulus of x graph, only difference in modulus is only difference in the modulus of x means like this. This is the modulus of x graph. So if we put x equals to 1, y equal to 1. If we put x equals to 2, y equals to 2. In this place, if you put 1, answer will be 1. If you put 2, answer will be 2. If you put 3, answer will be 3. Because there is no other number, no square, nothing. But only difference between modulus and other thing is, if you put minus 1, due to this modulus, it will make it positive. It will make this number positive. If you put minus 2 here within the modulus sign, modulus means take it positive, take the positive value of that thing. So the positive value of this is 2. Minus 3, if we put minus 3, then we will have plus 3. Ultimately, all of the things, if you put negative thing, output will be the positive. So that is the only difference. And if you try to draw the graph just roughly, your graph will be like this for the positive value, and for the negative value, your graph will be like this. You can try plotting it, and we have the graph here actually. We have the graph here drawn. See, this is the graph. This is the graph. If you put 0, answer is 0. If you put 1, answer is 1. If you put 2, answer is 2. 3, answer is 3. If you keep putting negative value, answer will come positive. So for minus 1, answer plus 1. For minus 2, answer plus 2. For minus 3, answer plus 3. And if you now look at the properties, the domain of this function is, as you can see, minus infinity to plus infinity. Range is from 0 to the plus infinity. And the graph has y-intercept. So x-intercept and y-intercept is 0, 0. And the graph is symmetric with respect to y-axis. See, this axis and this axis is same. This side and this side is same. So it is y-axis reflection. That means it is even function. The function is decreasing and increasing. So from 0 to plus infinity, this side is increasing and this side is decreasing. That means from minus infinity to 0, the function is decreasing, and from 0 to plus infinity, the function is increasing. The function has an absolute minimum. So this is the absolute minimum. This is the lowest point of this graph. And the highest thing we do not know, because since it is going to the infinities, highest thing we do not know here. Okay, so these are the properties of this absolute value function. In fact, this way we can continue discussing the other function. Let's say x square function, x cube function. We can draw them do different calculation, and we can draw them but after drawing, then if we look at the graph closely, we will start getting all these points. We will keep getting all this information from the graph. We will understand a couple of things like this from the graph. These are called the properties of the function. Properties of the function, and these are important actually. Now we have more library of functions. These are the more functions here. Fx equals to b. This is a let me write some number here. Suppose fx equals to 2 or fx equals to 3. Fx equals to 2. That means it is a horizontal line at 2. Then it will be a horizontal line at 2, like some line like this. Fx means y. That means y equal to 2. Y equal to 2 is here. Y equals to 2 is here. So the line will be like this. And if I say fx equals to 5, that means the line will be somewhat here. Okay, some horizontal line there. We can draw it from here also. Some horizontal line from here. So it will be fx equals to, suppose 5. Then 5 has to be here at that time. If I say fx equals to 5, this line is. Suppose fx equals to 5, if I say, that means 5 is at this point. This is 5 in the y-axis, this is the 5. And this is called constant function because it's a constant number. 2 is a constant number, 5 is a constant number. And this is called constant function. Fx equals to x, this is called the identity function. And this is like y equal to x graph. Something like y equals to x graph. Okay, y equals to very common graph in this pre-calculus. Very common graph. This line actually divide this axis, this quadrant into half, equal half. Another half is here, another half is here. So they actually divide this into two equal parts. And this is y equal to x. Why the line is like this? Because if you put x equals to 1, you get y equal to 1. If you put x equals to 2, you get y equal to 2. If you put x equals to 3, you get y equal to 3. So basically you are getting the same value for x and y. And if you put minus 1, x equal to, you get y equal to minus 1. If you put x equals to minus 2, you get y equals to minus 2. This side. This side. So you get x equals to 1, y equals to 1. You put x equals to 2, y equals to 2. Like this. X equals to 3, y equals to 3. Like this. If you put minus 1, you get minus 1. If you put minus 2, you get minus 2. If you put minus 3, you get minus 3. So basically your graph is like this. This is the identity function. Then square function is fx equals to x square. That is the square function. This is our square function or parabola. This is called the parabola. This is the function of parabola. X cube function is like this. This is the x cube function. You can try putting the value. You will see this. This is the graph. X cube function. And cube root function is this one, which we already we have drawn today. This one also we have drawn today. So this is square root function. This is cube root function, and this is cubic function. Cube function. You should know all this graph, by the way. That's why we are showing it. Automatically, like without looking at this graph, if we draw some graph like this, you should be able to say that okay, this is actually x cube function or x to the power 5 function. Actually, x to the power 5 function will be also something like this: x to the power 5, x to the power 7, x to the power 9. If this power is any odd number, the graph will look like this. Why? You can give a try. Okay, you can try to draw the other functions. They will have the similar properties. And okay, since I said that, here also it will be similar. X square, then x to the power 4, x to the power 6, x to the power 8. All of the function will be, their shape will be somewhat similar to this graph. Of course, it will not be exactly 2, 4. It will not be that value, but the shape will be like this. Maybe the graph will come here. Maybe the graph will, if we put some small value there, the graph will come here. But the shape will be this. Okay, the shape will be this, which is actually kind of giving us more sense about the what this power is doing. We have actually about them. Later we have more discussion on that kind of thing. We have more functions here. 1 by x graph, 1 by x. This is the 1 by x. Then modulus of x, we actually tried this one today. We actually tried this one today also. So modulus of x graph is this one. The x graph is two part here. One by x we have. You can put different values of x to see if this function is coming. Fx equals to integer value of x. Integer of x means integer is 0, integer is 1, integer is 2, integer is 3, integer is 4, integer is -1, -2. They are the integer. So only this is the solution, only this is the solution, only this is the solution, this is the solution. You do not have to draw the line. This means that only we have to only look at the integer. Integer means what? Integer means 0, 1, 2, 3, 4, -1, -2. They are the integer. They are the integer. They are the integer. So we just have to locate the integer when it is integer function. When it is integer function in the graph. Then we have our quiz 2 syllabus. Quiz 2 is October 5th, which is next week, and we have actually one revision class on October 5th about the pattern of the paper, etc., etc. We have a revision class. As you know, we always take a revision class before the quiz, so we have that thing coming up. Just to give you some heads up, this is the syllabus for our quiz 2. And basically these are nothing, these are actually 2.1, 2.2, 2.3 and 2.4. From 2.4 we have graphic functions and library of functions. This is what we discussed today, and the other thing, these other things actually we discussed in our last couple of classes. Okay, like identifying and understanding functions, that means which one is function, which one is not. Then finding some quotient and finding some difference product and quotient of two functions, the difference of this. So basically this means how can we combine two functions, fx plus gx, fx minus gx, that kind of thing. Identifying the graph of a function and obtaining information from it. So basically how to identify from the graph which one is function, which one is not. Then even function, odd function, you know, the y-axis reflection, then origin reflection, origin symmetry, then we get this. Increasing, decreasing, finding local maximum, minima. See, we actually discussed them. Then finding the average rate of change of functions, finding the equation of secant function. Average rate of change means the slope. Secant function means the equation of line from that obtained 2 points. Just last class we discussed these two things. So these are our syllabus for quiz 2. You can just have a quick look again back to all our slides from 2.1 to 2.4, or you can just look at this topic name. You will see that this topic name will match with our slides, so you can revise it from there and do a couple of maths from each of the sections that we are saying. Okay, that should be fine. And practice homeworks is actually from from for the quiz 2. You should prepare now for the quiz 2. That's the practice homework. That's the end of our slides, and I think that's it. We will soon come back with practice revision class video. Till then, everyone should practice and read, etc., etc. Have a good day, everyone. Thank you very much. Bye bye.